Hey everyone, welcome all. Myself Yash Sharma. I'm a student of Bennett University. I am pursuing my BTech here with computer science in specialization with artificial intelligence and machine learning. So, our today's subject of the video is automata theory and computability. So, our today's video will consist of some basic things of this subject such as DFA, NFA, and a little bit more. So, let us continue. So firstly, we have to see what the symbols are. So symbols can be a 0, 1, A, B, C, D to Z, and it can be anything. So these are represented as symbols. So what is an alphabet? Alphabet, we can say alphabet is denoted by this sign, and alphabet consists of symbols. When one or more symbols come together, then it is made as alphabet. So in this alphabet we have a set of symbols such as A and B in this, and in this we can say here we have A, B and C. Three symbols come together here to make an alphabet. Now from these alphabets we can see that these alphabets come together, all the basic composition made by combining these strings. Like we can say A is a string, available string here, ABA is a string, AAB is string, from this we can see ABC is string, ABBC is a string. So there can be multiple and endless strings which can be available from these alphabets right here. So now we have learned three things: symbols and alphabets, in which we have symbols as a set, and in strings we have all the possible strings of combining those alphabets together, or single, or all the possible strings. So now let us look at the fourth thing, that is language. What is language? So the language is subset of strings. There can be multiple strings as I told you, but if we abide any rule on it, let us say we have a string which will be starting from A, so it can be A, and further after A it can be anything. But what if our string starts from B? Then our language will not be accepting it, right? So is all the strings starting with A, are these the subsets of the string? Yes. So as a conclusion of language, we can say that it is a subset of strings which have some rules to classify whether the string is valid or not. So this string B, which is starting from B, and we have a language rule that it should start with A, so all these strings will be invalid. So we will get this subset, and then we will perform some machinery functions on these type of strings, right? So let us have a look at what finite automata is. Finite automata is the simplest machine which can recognize patterns. Finite automata or finite state machine have five elements. So what are the five elements? This is Q. The Q is finite set of states. Now you may be worrying about states, but we will be further in this video we will further see about what is states. As we know about set of input of symbols, as I told you, this is an alphabet. So as we have seen in the last slide, that this can be a set of symbols which can be like AB, ABC, anything like that. So Q is the initial state. What is Q? Here in we can write Q naught as the initial state, so it will be much clearer. So if I represent a state like this, Q naught, this is an initial state, and we represent this arrow as an input by the user or of the string which we want our machine to act on. So this Q naught here is an input state, initial state we can say, and where the string must be ending there, that set is QF, the set of final state. We can say here QF is the Q set of final state, this one. Now what is this transition function? Transition function means that on particular Q naught, on particular state, if I get any input, such as I'm getting input of my one symbol of this alphabet string, I'm getting input of A, right? So where I will be reaching? I will be reaching somewhere. So this let us say that I will be reaching to a state which is Q1. So what I will write, that transition of the Q naught state. Okay, first I will write transition function, then I will write on which state I am saying about this and on which symbol am I talking about. So transition of Q naught on A will lead me to where? What will be the answer? So the answer will be Q1. So like this, and if let us say by getting A I will go from Q0 to Q1, and even if I get 1A I will reach to the final state. Let us say like that. Okay, so now what I will get for this transition? For this transition I will get transition of set on set Q1 of which symbol? Of symbol A. What I will get? I will get QF, and the final state has two concentric circles. Final state can be represented like this. Okay, one circle, two circle, and here in between you can write the set name like Q1, Q2, QF. Any state can be final state. It depends on your language, right? So this is finite automata. Now let us look at some examples of finite automata. So let us look at that. We have one alphabet which is consisting of symbols AB. Okay, this is the basic one we have done. So now we have to, if we want to search every possible string, so what we will do, we will multiply this alphabet to itself, right? And then to itself, like we will say this to B. Here we can say A comma B star A comma B. So what will be the possible languages? AA, AB, BA, BB, right? So like this, here e's power is 2. Let us say e's power is 3. E's power can be anything. So what is the universal set which will contain all the finite automata? So we can represent it as e's power as star, where what will star refer to? Star can be anything. Let's say star can be 1, 1, 2, even 0 will be included. 0, 1, 2. Okay, here I'm having a little bit problem on writing, please ignore that. 0, 1, 2, 3, 4, right? So all this will be our e to the power star. So this can be our finite automata, universal automata. So any string which will be possible will be from e's star, right? If I have a b b b, something like that, so e's power can be something which will be satisfying all these constraints, right? So the universal, at last we can, in this slide we can conclude that e's power can be 0 to n, and then that e to the power n, e to the power star will be the universal set for all these finite automatas which are possible, right? Now, after learning the definition of finite automata and learning many things about finite automata, let us look at what is deterministic finite automata, or what is the need of deterministic finite automata basically. So as we have seen that there can be many strings possible, and it can lead to infinity. We don't even know what can be the biggest possible value for an finite set. Let us say that we have sigma, we have alphabet is equal to a comma b, and then its language should be more than 2. Then it can have infinite values of strings, infinite number of strings. It is not possible for us to tell that how many strings or language can it strings can be accepted in that languages, right? So we have to represent this type of strings into an finite automata. So for this there are multiple ways of doing it. So finite automata, to represent it as finite automata, so we can have finite automata without some output or with some output, but we will look at only and only this part right there, and even in this we will look at only these two parts because there is a lot of details which you must know about all this, and we cannot cover it in one video obviously, because all this is automata's core basic, right? Then we have to look at what is DFA right now, and then what we look about NFA. So let us move on DFA. Deterministic finite automata, as I said. DFA also consists of 5 tuples as I described in finite automata. In here, Q is the finite set of states, right? I told you Q naught, it can be Q1, QF. I will describe it further in numericals, you will understand it easily. This is the input set of our symbols, finite set of, this is our initial state as I stated, this is our final, this is our transition function, and transition functions can be defined as, this is the sign of defining and transition, this is our set of state on which we are considering the thing, and the alphabet or the symbol on which we are considering, and this leads to a state on which this one is going. Now the most important part of an DFA we can consider is, in this DFA, as the name says, deterministic. Deterministic means structural in itself, right? What is structural? Structural is something which is structured, right? That I cannot make it any way I want. I have to structure in some way. If you have to build a house, this that must be structured. So DFA is that house. Let us consider for why. So in DFA, let us say we want even cement and even bricks for building a house. So in NFA, we can say we can ignore cement, but in DFA we have to take both. And what is more structured? Obviously that brick and cement together are more structured. So deterministic finite automata is structure. In this type of finite automata, there must be only and only one path for every input, right? There must be a path defined for each and every input. This is the main point of DFA to be considered. Now, so we will understand DFA with some numericals. So let us see what this numerical says. So we have to construct an DFA with this alphabet as an input, which will be consisting of symbols A and B, and it will accept all the strings which are ending with A. Okay. So what can be the languages accepted by this? So it can be only A. The smallest string possible is, let us say, the string which is ending with A is the only string which is the smallest, right? If we have to consider first the smallest thing, which will be the very easiest part of DFA, is that consider the smallest string possible, right? So A can be the smallest string possible, then it can be A, so here as we can see, A the smallest string possible here, and then A is also, all the strings or in this language which will be accepted is ending with A. So let us see what are the rejected strings then. So these are the rejected strings which end with B. So these will be the rejected strings. So now how we will construct the DFA is, first we will take an input sign, right? What will be the input of our DFA? So let us consider like this, and as I stated that we take our input state as Q0, right? So you can take it any way you want. Now let us say that it ends with A. So what if my string end with A directly? If I pass the string A, then it must go to final state, and what we can name anything the final state, but it will have two concentric circles as I have said earlier in my video. So we will name it as QF, right? QF. Okay guys, this is a bit now what if B comes? Now as I said, we have to define each and every possible output of every string. So what if B comes here? So if B comes here, then what we can do, that we won't let this string end, we won't let this string go to the final node, we will let it be to the input only. So if the B comes, then it will be on Q0 only, the initial state only, and it won't go further until A comes. Now on every state we have to define the transition. That is the most important thing here. So defining the transition state of symbol A on final state. What if A comes now? If the A comes after A, then the string will be automatically ending with A, so we have no problem. We can give a self loop here, that okay, transition of A on QF also goes on QF state only. And what if B comes here? Then the string will be ended from B, so it should not be accepted. So what we will say, okay, go here, so that you will, it won't be reaching final state until it get A in it. So this is our finite DFA for all strings ending with A. So here are some questions for you which you can try on, and you can comment if you do not get the answer. I will be answering, since the video can be very long, because of that's why I'm not solving it. And yes, I have some solved answer of them. So if you want, I can record another video of answering in notebook, and then I will upload it. So that will be quite easier. This here takes a lot of time. So these can be the question. DFA of AB accepts all string of length 2 here, right? Of length 2. So what it will be? It will be AA, AB, right? It can be AA, AB, okay, BB, and BA. It will accept only and only these strings, these 4 strings, right? Because only these 4 strings are of length 2. So how we will make the automata? Let me erase it first. So how we will describe this automata? We can sorry, we can make this automata as this can be the input. Now only 2, so q naught. So we can pass a or b, doesn't matter. So we can write like a comma b. So if anything comes, the transition is defined, right? Q1. Like if I want to write transition here on q naught of transition of a goes to q1, also q of transition of b on q naught goes to q1. So okay, it is defined. Now if I give an input of a and b, also a comma b, anything that can be. So here the string of length 2 will end, right? A can be it can go to qf, right? Final state. Now let me ask you a question. Is our automata complete? Take 2 seconds, think for 2 seconds and then answer. Is our automata complete? No, our automata is not complete. Why? Because we haven't given any decision, any transition. We haven't stated any transition on this QF, right? We have to state the transition on QF also. So here is the thing, which is dead state. It means that dead state, if after going to the dead state, the machine won't perform any function. Yeah, after going on 2 strings, if I get any 3 strings, any input such as A or B, I can declare it as a dead state. Dead state, it means machine won't work after that. Machine won't accept anything after that. Okay. So we can name as QD, right? And is our automata complete now? It is A, guys. Let me draw it. Now it's also not complete. On QD, we have to define the transition of A and B. So as I told you, only if one dead state comes, the dead state have loop on it of a and b, because if once the dead state comes, the machine won't accept the strings after that. Now you can see that all the strings of length 2 will be accepted by this DFA, and if they are less also, they will be rejected or they won't reach to the final state, and if they are more, they will go to the dead state. So these are the questions. These are some starting numericals, and this can also be done by you accepting with start with a. If we have done end with a, that's this is on. And this you can do it here. It says number of a's must be divisible by 2, or it must be even. So this can be an you can say a bit difficult, not that difficult, it is easy if you think. And this can be a bit difficult. It says accepted the string which starts and ends with same symbol. So these are some practice DFA questions if you want to practice. So let us look at what NFA says. Unlike DFA, in NFA there is no need to define transition for every input. That is why it is easy to build NFA, right? So the transition function, where in DFA we said that okay, this q to the alphabet is q only, but here it is 2 to the power of the state q, right? The transition of function for NFA is multi-valued, whereas in DFA it was only single valued. So in NFA we do not have to describe each and every transition. Like in DFA we did, if for a we have defined, we also have to define for b. In this if we have defined for a and we left for b, it's okay. But in DFA if we do like that, our question will be incorrect, our answer will be incorrect, right? Okay, so solving these difficult problems of DFA with NFA. So we can solve DFA problems with NFA easily, because we don't have to show the transition for each and every state. So AB accepts the string which starts and ends with same symbol. So this was difficult during DFA. If you want to solve it with DFA, it will be very difficult. And let us see what we can do with it in NFA. So let us say that okay, if I start with A on Q0, if I start with A, then I can say okay, I go to Q1, right? And I can go to A only to QF, right? this is my final state, guys. If I draw a circle here, so I will mark it as star. You can say this is final state. And if I go to B, right, if I go to B on Q0, then let us name one more state Q2. And if A comes, I'm not defining because it is an NFA. We do not have to define a transition for every state, no, for every alphabet symbol, sorry, for every symbol. So if B comes here, we will go to the QF, right? This is an easiest NFA. So if DFA, we would have to define B here, B here, B here, A here, and A here, B here. So that will be a bit difficult. Now there are tricks, and there is a theorem in which you can convert the NFA to DFA, which will be much easier than creating the DFA itself. That can that can lead to inaccuracy. Yes, you can draw DFA, but it will be easy if you draw NFA first and then apply the theorem of converting the conversion of NFA into DFA. So that's it, guys. And all right, guys, thanks for watching. If you have any doubt, you can comment me and ask about it. And see you all in next upcoming videos. Stay tuned, like, share, subscribe. Bye bye.